All right, so today I have the absolute honor of speaking to you about some of the new features that Synthase offers. So over the last year, the best and brightest brains that we have to offer have been creating something very special within the Synthase digital experiment platform, DOE. So what I want to do today is hopefully resonate with a few of my fellow scientists and talk about the pains of DOE experimentation. Then I'll demonstrate the new features that Synthase offers and without being too dramatic, tell you how I think these features are pretty life-changing. But first, for those who aren't too familiar with DOE, I'll give you a very quick rundown. So traditionally, experiments are undertaken by measuring the impact of changing one experimental factor on a given response. But DOE, or design of experiments, is the concept of measuring the effect of multiple variables on a response at the same time. We do this using applied statistics. And there's numerous benefits to this, but the most compelling, I suppose, is the fact that DOE accounts for those interaction effects between factors. And this is key because the effect of one factor or variable might be linked to another factor. So if you were to just measure one factor at a time, you simply wouldn't account for the relationships between factors. DOE's got a ton of uses. In biology, it's particularly important when we want to optimize a process or output. So a common example that we use is optimizing cell growth media. So now we're on the same page with DOE. Let me talk to you about some of the new DOE features that Synthase has to offer. So I'll start with the pain points, and then I'll demonstrate how the Synthase platform can really help. So let's talk pain points. What are our daily struggles as scientists? And why is DOE so hard for us to begin with? Now, the first pain point is DOE itself. And one thing I'm quite passionate about is the fact that DOE is inaccessible. I've lost count of the number of scientists I've spoken about DOE with, where they've heard of it, they recognize its value, but they don't really know where to start. And when we hear about DOE, we get this barrage of jargon. We're faced with confusing software, or if we get far enough, we're hit with unrealistically large experiments. And so I met a scientist who wanted to investigate 7 factors in their experiment and measure them at 3 levels each. That sounds reasonable. But to their shock, they told me that this equated to over 2,000 runs. And even if they had automation equipment and the experience to do that, it's a lot of runs. Now, some of you will say that they've picked the wrong design, and you'd be right. But the bottom line is that DOE can be daunting. And this is only heightened when you try to use DOE design software that, let's be honest, can be quite unintuitive. But don't get me wrong, stat software can be immensely powerful for DOE experts. But to say the learning curve is steep is a huge understatement. The next pain point is experiment management. So as a scientist, you might want to plan out your experiment in a spreadsheet and generate your DOE design in a stat software, go back to your spreadsheet to create your experiment method, plead with your automation engineer to translate it into device instructions, run the experiment in your lab, generate a ton of data, often in different file formats, and then you have to align or compile those data somehow. And even if you get that far, there's really no time to pat yourself on the back because you're faced with the final point, data analysis. Let's be honest, we all dread that mammoth task of generating those useful findings, maybe using a stats or graphing software. And perhaps you're a biologist, you're not a stats expert. So making some sense of those data can be a real struggle. Where do you start? And if that wasn't enough, DOE is an iterative process. You might have to do all of that multiple times over. So now I've got that off my chest, let's talk solutions. It's not all doom and gloom. So with Synthase, DOE really couldn't be easier. So let me show you how it works And I've got a video that I'm going to play as I'm talking. So first, a scientist can plan out their experiment using the Synthase Workflow Builder canvas. They can effectively map out their experiment, which will create instructions for a robot in the lab or for you to follow manually. So I've taken this simple example that I mentioned where I'm designing a DOE experiment to optimize my mammalian cell growth media. So first I define my stock liquids that I'm going to make my media from. And to do this, I'm using this brilliant little element called auto-generate stock solutions. By defining my stocks in here first, Synthase will automatically tell me the ideal stock solution to prepare in my lab for this experiment that will satisfy my final desired concentrations, all whilst preventing my liquid handler from having to prepare minute volumes, which might be quite inaccurate. I'm also defining sterile water in here, which I'll be using as a diluent. Then I'm connecting these liquids to a make mixtures element, which will make mixtures from my stock solutions and my diluent. And all I have to do is add some extra info, which will tell the element how much volume I want to make, and then tell it that sterile water is my diluent and the plate that I want to make the mixtures onto. But this is where it gets neat. I can then toggle into DOE mode. And this highlights all the stages in which I can apply a DOE design in my experiment. In this case, I'm going to add the DOE design to my mixtures and specifically my mixture components. From here, all I've got to do is enter the components that I'd like to add as factors to my DOE design, and then the specific concentrations or volume levels of each. So once I'm happy with that, I can hit Calculate Design. So Synthase will then present to you 3 DOE designs to choose from, and Synthase will generate those designs using the information you've provided. So here I'm choosing a space-filling design, and I'm shown the statistical power of my design. And this sort of indicates the probability, really, that the design will collect enough data to confidently identify real active effects. Now, this really solves our first pain point, and irrespective of your prior DOE knowledge, you're presented with 3 design options, and you're told how powerful those DOE designs are. So you're not just giving DOE a go, you're able to create powerful experimental designs. Now, of course, if you are a DOE expert or just prefer to use your own software to generate the design, you can upload that in a CSV file format using the Upload Design button. So once you've chosen your design or uploaded it, you can then simulate your experiment from the comfort of your own home or from your office or, I don't know, the Elizabeth line, wherever you want, and preview exactly how your robot in your lab is going to execute your experiment. So here I'm checking the deck setup, the DOE design, and then I'm previewing exactly how that experiment will run in my lab. And then with a couple more clicks, I'm sending that simulation to the lab. And then all you've got to do is set up your robot and press run. Once that experiment's finished, you can then upload the data, or depending on your experiment or your equipment rather, have that data automatically uploaded, not just to Synthase, but to the experiment you've been working on. And it's worth mentioning at this point, with Synthase, you're able to align data from multiple file formats and multiple executions. From here, I'm clicking Structured Data, and that will transport me to a response analysis. So in this response analysis tab, I can immediately eyeball my data. And then I can jump on into some in-depth analysis. You can create models here, you can explore them, go on a little adventure with your data, and then generate really powerful insights in the same software that you started your journey. And when you're happy with your models, you can save that analysis to a read-only state, copy that link, and share it with your colleagues. They can then have a look and marvel at your beautiful findings. But jokes aside, what you've effectively done there is packaged your entire experiment into one software, from design right through to analysis. And you've been able to take that experiment and send that to your colleague. Just think about that from the standpoint of transparency and reproducibility and efficiency. Your method, your data, your findings, and your analysis, it's all there in one link. So now you've seen the product, let me summarize. So those brains at Synthase have created two things. The first is accessible DOE. So without having that prior knowledge of DOE, you can generate a design and immediately understand how powerful that design is. You didn't need a stats background. You didn't need to use multiple different apps. And the second thing that Synthase has created is really a complete uproot of how we do experiments. And the absolute buzzwords here really is end-to-end. Synthase has allowed you to plan, design, simulate, execute, and analyze in one app. Not a spreadsheet, not in a stats program, graphing software, liquid handler software, plate reader software. One app, Synthase. Thank you so much for listening to me today. If you're interested in what we do or have any questions, just pop those questions in the chat or contact us afterwards. And if you're interested in having a chat with me or anyone else about the cool research you're doing and how you're using or not using DOE, please feel free to reach out. And I'll be answering any questions in the chat now. That's all from me. Have a great day.